So this is a work function problem, and our formula for that is that the maximum kinetic energy of the photon or the electrons that escape the metal is equal to the energy of the incident light minus the work function. Right now, the energy of the incident light in this case can be found with hc over lambda. We're given the wavelength. So let me write that out. There's h and there's c, and lambda is given to be 425 nanometers. Okay, so that works out to be 4.68 times 10 to the minus 19 joules. Now you got to be careful here because, okay, so kinetic energy max is equal to, if we try to do it like this, joules minus 2.24 eV. That doesn't make any sense, right? These have got to be in the same units. So this has to be converted into EV. It's 2.92 EV minus 2.24 EV. So that gives us the right answer, which is 0.68 EV. Now I can convert that into joules if I want. That's 1.09 times 10 to the minus 19 joules. And actually I need to do that because if we want to find the velocity of the electron, we're going to have to use the formula for kinetic energy. 1/2 mv squared is equal to 109 times 10 to the minus 19. Okay, so now the mass of the electron is 911 times 10 to the minus 31. And if I work out that algebra real quick, I get a velocity of 4.90 times 10 to the 5th meters per second. Okay, that's part A. Then part B is asking what's the cutoff wavelength. Well, the cutoff wavelength occurs where the electrons escape with the minimum possible kinetic energy, which is 0. So they barely escape, with like 0.0000001 eV of energy. So that means that the energy of the incident photon must equal the work function. Okay? So we're going to set hc over lambda cutoff equal to that work function phi. Okay? Now, let's see. So 6.626. There's h and there's c. And then here's lambda. Now that work function, the 2.24 eV work function, that is 3.58 times 10 to the minus 19 joules, right? 2.24 eV becomes that. But I want everything in MKS units. And so that lets me solve for lambda cutoff, which is 555 nanometers. Or if, your calculator spits out 5.55 times 10 to the minus 7 meters. But I read that as 10 to the 9, 555 times 10 to the minus 9 meters, which is 555 nanometers.